we are cruising on to CO23, which even though it's a CO, you should still do your homework. Still important, okay? And we're talking about corresponding parts. And this is the last objective before the the four-parter of doing proofs. And part of doing successful proofs. No, I'm not joking. I'm not joking. Part of doing successful proofs is identifying what are called corresponding parts. Because by reading the proving statement and reading the given statement, you have to know what you're reading, right? Geometry, like we said several times before, it's like its own language, okay? And so how geometry kind of communicates things to you is oftentimes through what are called corresponding parts. And corresponding parts are sides, I'll say and angles. Sides and angles. And this is a very elementary definition, but I think we're going to start with this here. Sides and angles that match up between two shapes. Okay? Sides and angles that match up between two shapes. We'll get a little more technical than that, but I think this is a pretty good place to start. And a congruency statement is a mathematical statement that identifies corresponding parts. Congruency statement is a mathematical statement that identifies corresponding parts as being congruent. I guess I should say that too.
I have to put mathematical again to the statement.
What do you think?
We're in math.
What do you think?
We're in math.
Those that go the extra mile are more fit than those who don't.
That's so very wrong.
You're so wrong.
Eventually.
That's fair, David. You should be know what instrumentation is. Do you ever think?
What?
Do you ever think that when you're talking?
What?
I got hit on the head by Enzo. So
He did. He's got a bump right here.
Do you know what you're gonna say?
I don't
Be
know.
inspirational.
Do you want to give it a try?
Don't you mean inspirational?
Yes. Inspirational speaker.
Oh, thank you, James. That was the one recommendation.
Do you
What?
ever think when you're in like the teacher's lounge and you're making a joke that the teachers are just laughing because they feel bad for you?
No. Mrs. Kirko legitimately thinks that I'm hilarious.
Okay, but like this
She does not. And Mrs. Thomas goes back and forth.
I'm called Cat.
Boyle thinks I'm funny too, though.
I think Mrs. Sue and Mrs. Thomas have.
He's like a nice guy though.
Okay, so first of all, identify all corresponding parts, then write a congruent statement. So again, corresponding parts are sides and angles that match up between two shapes. So we'll start with the angles. They're a little bit easier, okay? Angle A is congruent to which angle, or there's no angle A, that was dumb. Angle K, sorry, angle K is congruent to which angle in the second shape? And how do you know?
The lines.
Okay? I heard someone say, I thought this said S.
Oh my gosh.
There we go. Angle K is congruent to angle X because they're both marked with one arc, right? If you'll notice, this second shape isn't kind of rotated, turned, flipped, whatever happened to it, K and S, they match up. And they match up because they're the same measure, and we know that because they are both arced with a single arc. Okay? Angle L is congruent to which angle in the second shape? Luca?
R.
R, because they both are marked with two arcs. Okay? And finally, angle J is congruent to angle T, because they are both marked with three arcs. Okay? Yes?
And then for like the sides, would it be like JK and then a line over it?
Okay, so for the sides, You wouldn't need a line over it because if you're talking about the measure of something, if you did put a line over it, it would mean segment, but if you're talking about the measure of something, JK is just fine there. But we are going to put a line over to show that it is a segment. JK matches up with which side on the other triangle, and you've got to be careful here. Not ST.
TS.
TS. What's the difference? Well, ST says we're going from point S to point T, which is the same segment as going from point T to point S. However, because in our first segment we went from J to K, which is our 3 arc angle, to our single arc angle, we must go the same direction when naming the second shape. We have to go from T to S.
What if the angles aren't
Yeah, that's
congruent?
exactly what I was
Okay? What's that?
What if the angles aren't congruent at all? In which direction do you have to go?
Then we wouldn't have corresponding parts.
But
But
the line could be the
the
same,
line
but the angles
can be
wouldn't.
drawn.
Gotcha. In that case, you would go.
Is that a really good spray?
You'd have to figure out how the shapes would.
Would you just go like biggest angle to smallest angle? Or-
Mm,
You know how to knit?
in that case, I don't know what would matter. Actually, I'm trying to think. I don't think it would matter.
So if you do know, you have to do
Yeah,
it correctly.
yeah,
If you don't
yeah.
know,
Yeah.
How
Gus.
does S to T change the measure of the line?
It doesn't. It doesn't change it, but if we start with our 3 arc angle, this angle, and go to our single arc angle, we have to go the same direction on the other shape.
Why?
It's how it's done. Geometry,
So it's basically
language,
just a quick
notation.
one.
It's like, why is through pronounced differently than enough? It just is. Spelled the same ending.
That's English is
That's what
stupid.
we're talking about.
Yeah, they both end in O-U-G-H, but one's pronounced through, one's pronounced enough. I don't know why, just the way it is. Tatum.
there's the
Sure. The next one, will give me another pair of sides that correspond here. Evan.
J and L, and T and R.
Good. Side JL and side TR. And again, pay attention, the direction here. J is our 3 arc angle down to our double arc angle. We have to go the same way from T to our 3 arc angle to double arc angle. Last pair of sides. Hugo.
I just, like, can you, how many angles and sides do you need to know to determine if the triangles are?
3. And we'll talk about that in Peel's 4, actually. You get to wait a day. 24 hours from now, you'll know.
So there's 4 parts.
Oh.
Right, but most of them are just doing proofs. The knowledge comes in part 1. Third pair of angles, or third pair of sides. L, is that hand up? No. Chance, have your hand up?
I gave up.
Okay. Evan again.
K and L and S and R.
K and L and S to R from our single arced angle to our double. From our single arced angle to our double. Side KL is congruent to side SR. Okay. So, these are all the corresponding parts. Okay. Now when it comes time for the congruency statements, you can go in any order as long as you keep it consistent between the 2 triangles. For example, one possible congruency statement might be triangle KLJ is congruent to triangle, and because I went from my single arc to my double to my triple, I have to do the same thing here. Single, double, triple. SRT would be the correct order. Okay? Triangle KLJ is congruent to triangle SRT. And that order matters because I went from single, double, triple, single, double, triple. Okay? What if I went like this? What if I said that triangle LKJ? LKJ, what would the second part of that be?
RST.
LKJ, I went from double to single to triple.
RST.
So double, single, triple here would be RST. Right? And the beauty of this is that within this congruency statement, it gives you all the corresponding parts, all 6 of them. For example, K comes first, S comes first. We have K and S marked. L comes second, R comes second, L and R. J third, T third, J and T. Segments 2, look at this. KL, our first 2 letters of the statement. SR, our first 2. We have KL and SR marked right there already. Okay? Our third letter, J to K, T to S, we have that marked there too, J, K, T, S. So all you need is a congruency statement, and it gives you all 6 of these parts if you know how to read it. And that's where the challenge comes in, and that's why, even though it's a CO, we still need to do our homework. Because if you don't know how to read these things, it makes CO24 even more complicated than it needs to be. Okay? All right, good so far. We're good on the notes here? Okay? Question, yes.
Do we have to write the line above JK?
We have what?
Write the line above JK
For now, yes. Yeah. No, you didn't. You closed it. You quit. Don't give me that. James.
What is the most massive math equation you've ever done?
I don't know off the top of my head.
Well, did you know like last year, if you were hard enough at the beginning of the year?
The third angles theorem. If 2 pairs of corresponding angles in 2 triangles.
Oh.
So we're using the word corresponding a little bit differently than we were with corresponding angles with parallel lines. The reason why they're called corresponding angles with the lines is because they're in the same location, which is kind of the same thing that we're doing here. Okay? But now we're shifting from lines to triangles now. Okay? But if 2 pairs of corresponding angles and 2 triangles are congruent, then the third pair is also congruent. And we'll draw a nice little picture to help us visualize what this means here. But the third angles theorem says that if 2 pairs of corresponding angles and 2 triangles are congruent, then the third pair is also congruent. So, do your best to draw 2 congruent triangles.
Like 2 different triangles?
Yup, but congruent.
What's that mean? Oh, no, well.
More or less the same size and the same shape, give or take. Okay?
Wait, I do the exact same thing.
A triangle?
Yeah, but it was
I
like
do a-
that.
I do a square.
No,
Triangle.
like look.
That's
It's not gonna work.
amazing.
Why not?
So, what the third angles theorem says,
I drew the exact same
Whoops.
thing.
it says that if 2 pairs of corresponding angles and 2 triangles are congruent. So if we know that 2 pairs of these corresponding angles are congruent, right? We have the bottom left and the top one. We know that those 2 pairs of angles are congruent. Then the third pair has to be. Why does that make any sense? Even if we know no measures at all, why does it make sense if we know that 2 pairs are congruent, the third one has to be? Evan.
Because both triangles will add up to 130, and
Yeah.
both sides are the same.
Yes. Okay? Remember, a triangle has to have exactly 180 degrees in. Whatever degree measure this is, it's the same. Whatever degree measure this is, it's the same, which means there's only a certain number of degrees and the same number of degrees left for our third angle. Right? So if you know 2 of them, you can conclude the third pair based on the third angles theorem. Not happy. Okay, in the diagram, and this is the congruency statement that you'll see when writing proofs. Yes, you go.
Does a quadrilateral have a 4th angles theorem?
Well, I
Does a
mean,
pentagon have a
yes,
fifth
but
angle?
it's not called that.
Wait,
Yeah.
Does a
But yes,
pentagon have a
in
sixth
theory,
angle?
yes. Pentagon 5 angle theorem.
Is that it's also true about the sides,
That's
right?
7, guys, not 4.
Like if 2 sides
Oh, my bad.
are congruent, then like
Depends on what the angles are inside. We'll learn all of that tomorrow. Right? Okay, so this is your congruency statement, and this is how you read it. It says in the diagram, DEFG is congruent to SPQR. Now, when shapes are rotated and flipped and whatever else like this, it can be hard to tell what angles match up. The congruency statement tells you everything, right? This tells you D corresponds with S, angle E with P, F with Q, G with R. It also tells you that, for example, side DE corresponds with side SP, or side EF corresponds with PQ, FG corresponds with QR, and GD, going from the first or from the last to the first, GD corresponds with RS. So everything you need to know about the shapes and like what matches up with what is told to you in the congruency statement. Okay? So, what is the value of x? Here's our x side, QR. What does QR match up with? QR is congruent to which side on the other shape? FG. Why? Because third and fourth letters match up with third and fourth letters. So, if QR is equal to 2x minus 4, that's got to be equal to the measure of FG, which is 12. So 2x minus 4 equals 12.
I know.
You don't get it?
No, I know how to do this.
Oh, good. What's the value for x?
I can do it.
Oh,
8.
it is 8. Okay? Questions on that? How about the value of y? Okay, our expression with y is right here.
I know.
Angle Q. Angle Q corresponds with what angle in the other shape? F. And how do you know that?
Because it's congruent.
Third letter, right? These congruency statements are in a certain order for a reason. Q is the third letter of that shape, so it has to match up with the third letter of the other shape. So Q is congruent to F. Angle Q is 6y plus x. Well, we know what x is. X is 8, so we can fill that in there. Okay? And then angle F in the other one is 68. So 6y plus 8 has to equal 68. Y equals... In my head I was thinking 20. Whoopsie-doo.
Literal recommendation.
Okay. Okay, and so you got 4 to do on your own. Then it says, remember the reflexive, symmetric, and transit properties we use with segments and angles. They apply to triangles too. Not really a nifty tidbit, but I haven't used my avatar since CO13.
What's the avatar?
This thing.
What?
That's me.
Oh.
Yeah.
Holy shit.
Well, when I have more hair. But, yeah.
When you were the Elite Eight.
Ooh, chop.
Yeah. Look at that flow.
I need to text you.
Yes, they were all in 8th grade.
How old were you then?
How old was I? That was 2014, so 30. 10 years ago.
Actually, no.
14.
You would have been.
Boy, I don't see it. It's right.
You mean like
When that picture was taken, I was.
What's the? Oh, that.
I feel
How
like
does he just like throw this? Why is he
Well,
I'm sure they did.
maybe the second one to the left or right.
Adam?
Yeah.
Yeah.
But the rest.
Chris just said he wasn't born until
Molly? No, they're all doing well right now.
Are they not?
I don't know. I haven't followed up. Okay, on page 228.
is this homework?
Page 228, you are to do 5 through 10.
Is there a comma? Anything over 10 questions right now?
He's like, I can get right. Easy on the road.
James.
5 through 10. 15 16. And I think in 19 and 20, you're going to need to use systems of equations.
I don't even know what it is.
No, let's not do that.
I feel like elimination. What is that?
Elimination, yeah, oxenoid.
Oh.
So 19
I am not doing this. This is not good.
Not
and
even John.
20.
Oxenoid?
It was a PO. It was on your entrance exam. The PO last.
I remember it.
It's going to come back in algebra 2 with 3 equations and 3 variables. Okay.
I do all the other
I'm not taking.
It's going to come back in algebra 2, only with 3 equations and 3 variables.
Guess who's dropping out?
Yeah, I'm dropping.
You can't drop out of algebra 2. It's a required course. Sorry.
Of high
You
school.
can't physically make me go to class.
Correct, but we
don't
also
want- Wait, yeah.
won't let you graduate.
That's fine.
What happens?
You do you, Tatum.
I'll do that.
That's on math.